Yo, what's up? Today we'll learn about how to modify the data, like the prediction value, so we can learn like the real correctness. So first of all, I will do a brief summarize of the thing we did on the last video, that to predict the age of the abalone. So first of all, we imported libraries that's necessary and not necessary. We read it in the file, which is here. We imported our library and set the amount of neighbors to 3. We drop the sex column because we don't need it. Sorry. And then we drop the rank for the x because the x is the input data, so it doesn't need the answer, obviously. And then the y is, which is the data ranks, which is a target that the model want to predict. And we use the train test split. So basically it means that this means we give the 20% of the test to the testing data set. And then the rest 80% to the training data set. So X train and Y train is the training data set. So the X train is the all of these, which are the, I will say, the variables that's and the input that's given to the model, which is used to predict these. So the X train is these data that we are feeding to the model, and this is the Y train, which is we also given to the data that we wanted to predict. And then now the X test and the Y test is what we will use to predict, like, it's data that the model and the algorithm is not familiar with, and we will use it to see the accuracy to prevent stuff like overfitting and underfitting, which I will talk about in the future. And then we'll just, this line just means it will score itself, and we got a 20%, which is not that good compared to the models we did before, which is basically have a high 90s accuracy. This is because the one we're doing this time, it's a regression prediction. So regression basically just mean we're predicting a data, like predicting something that might have an answer range from one value to another, which is 0 to 25 according to the diagram we've seen on the last video. And this will make the algorithm harder, because in a regression model there will be like a lot more prediction than like a classification model, which we did before. Since classification model, you just need to separate the data into like maybe at most 4 piles. So even if you just made a model guessing randomly, it will have a 1/4 chance. However, for this data set, like if you just giving a random model, the possibility will be just like 1/25th, which is very small, and this is why regression model usually have a lower accuracy. So what I will do today is that if our prediction value is the range of +3 to -3 compared to like the real age, then we will count it as correct. And when we actually do that, we'll see that we have pretty good score. Though it's not really high 90s, but 80% is pretty good. So what we will do is first we'll declare this variable called accepted, which is just the quantity that's like in the range of 3 to -3 with the like correct answer. Basic just mean it's like not further than 3 compared to the real age. So first we will iterate through the data. So print equal to model.predict x test. So this just mean what the model think x test will be, and obviously y test is a like actual like number, like the actual answer. So we'll iterate through the data, and then if interesting trick, we don't really need to do two if statement for the -3 and the +3. We can use the ABS, which is the absolute value function. So if print I minus y test I is, if it's less than or equal to 3, then accepted will be 0, and print accepted divide by the length of pred, which is so divide the quantity of how much it's considered correct by how long the data is, we will get our final value. And this is, oh shoot, not equal to 0, is equal to accepted plus 1. And this just means if we subtract it. And there's a small error. Can you identify it? Yeah, so the error is that, which is quite important, the y test is actually a, actually I will do this first. Print type of, doesn't work. Print type y test. I'm pretty sure this should work. Let me see. Yeah, so we'll say it's a pandas.core.series, which will make it like we cannot use an index to just do it. We're gonna use its function, which is pretty important. It's called integer log, which just finds where it is with like a pandas series. So it's basically just an index, but you just add this since the y test is not really a list or a numpy array. And you see now we will have a pretty good chance, 84%. And yeah, this is basically how you do it. And then we'll learn about like another concept. It's a mean square error. So this equal to mean square error y. It's like y test and pred, then print sqrt RMSE. So like this. Yeah. So mean square error is just basically looking at how much our prediction value differs from the each of the like the real age, and then calculate like the average of it. So what I will do is, first of all, let's say we have a list of 1, 2, 3, 4. Maybe we can have -1. So the mean square error will be, let's say, will be like the correct answer for all of them is like 0. So 0. And then, so first of all, we'll look at the difference. And then this, we see difference is 1, and then negative 1, and then -2, -3, -4. The I the process might be like flipped, which is this one might be first, but that doesn't really matter. And then what we'll do is we will square them, since we need to make it like these integers a positive number. Otherwise, it'll just like cancel out, which we will not really get like what we want to get. And then so this is why we use the square root function. So, and then it would just be 1 plus 1 plus -2 squared, which is 4, plus 9 plus 16, which equal to, so this will be 6, 15, 20, 31. So this will equal to 31. And then we have 5 data here, so 31 divided by 5, which equal to 6.2, I think. So 6.2 is what, like, how much each of these average it out differs from the correct value squared. So that's why we need to square root this, and this is like, so the correct answer is about like 2.3, I guess, 2 point something. So this is basically what the mean square error, like, its basic algorithm is pretty simple. Yeah, and basically that's it. Bye.